This was published in way back in 2003 in RBN Online, and this talked about isolation of motile spermatozoa of semen by microfluidic technology. Repetitive centrifugation and resuspension of the sperm pellet successfully removes all the seminal plasma and macrophages, etc., but still may not select a motile sperm. For the motile sperm to be selected, you need to overlay with a media and allow the sperm to swim up. And when you do the centrifugation repetitively, obviously the sperms can be damaged by reactive oxygen species, and there's a possibility you may pellet the senescent sperms, and some neutrophils and epithelial cells could still be there. And if you don't offer any centrifugation, if you just allow some media to overlay an oligospermic sample and allow the swim up, oligospermia semen sample, the recovery could be still poor. There is a study by Zini et al. Published in 2000 which talks about a density gradient isolates motile sperm but increases the sperm DNA fragmentation because of repetitive centrifugation process. A microfluidic, as shown in the picture, is a mixture of two channels. There is a stream of semen which goes through the upper channel, which goes in a linear fashion. In the lower channel, there is a laminar flow of media is established. And as the motile sperms come in contact with the laminar flow in the media, those get selected and they come out with the media further. And this is the typical microfluidic technology basics. And as the fluid diverge, the motile sperms get selected. A typical microfluidic chip is like this, which will be having a thin inlet and a thin outlet for raw semen to be inserted from one end to come out, while the wide inlet and wide outlet is for the media which flows and takes the motile sperm with it from the wider outlet. And all the stream has to be established at room temperature. Look at the yield. In this particular study, they said that the motility and morphology both were better compared to the initial sample in a sorted sample. There is a subtle advantage of this technology. Semen with large amount of debris, this is much better technology because all that debris can increase the reactive oxygen species and cause sperm damage and fertilization failures. High sperm DNA fragmentation samples can be processed by microfluidic again, and sublethal damage due to centrifugation is completely avoided when you use microfluidic technique. If you find that the motile sperms are less recovered with one go of microfluidic, whatever you recovered of the semen outlet can be refed into the inlet and you can go at 1 or 2 more rounds. So ultimate recovery could be better. Density gradient technology can select sperms with damaged chromatin and high sperm DNA fragmentation. Swim up is better than density gradient for reducing sperm DNA fragmentation, but microfluidic is the best. The efficiency of microfluidic technique will depend upon the rate of flow of fluid stream and the duration of contact of parallel stream and the sperm motility parameters. So what I understood is going 2 or 3 rounds with microfluidic can give you a better motile sperm concentration which can be used for IUI. So I'm sure this microfluidic technology can be safely be used for couples who are having high DNA fragmentation with more amount of pyospermia and high semen debris, also for couples who have not had a good quality embryos or have repeated implantation failures, or all the men who are obese, men with the age of 40 or beyond, or having diabesity, that is diabetes and obesity. You can definitely use microfluidic electively for these men so that you get a better